looking at circles. So circles have a very distinct equation, and you'll be able to pick up the equation of a circle really easily. They exist in the form x squared plus y squared equals r squared, or alternatively as x minus a squared plus y minus b squared equals r squared. So this is your basic equation of a circle. If you've got x squared plus y squared equals r squared, and the center is 0, 0, and the radius is equal to r. So in general, the domain and range of this basic function, the domain is between r, x, and negative r, and the range is r, y, and negative r. Okay, so essentially the reason that is because your radius spans the widest point on your x-axis on both sides. You'll have r and negative r as the widest points, and then y and negative y as your shortest and tallest points. Then the equation of a circle with the center A, B, and radius r is given in this format. So you'll have x minus a squared plus y minus b squared equals r squared. Okay, so essentially when we're looking at this as a more complex equation for a circle that's had some movement to it, we can find the radius of, the center of our circle with A and B. Okay, it's important to notice here that minus A and minus B give you the coordinates A and B for your center. If you had x plus A and y plus B, you'd have the coordinates negative A and negative B. Okay, so the center is the opposites of what we've got going on here. And then again, the same thing, your radius is the square root of whatever all of that's equal to. Okay, so next example question, I want you guys to have a go sketching this circle and stating its domain and range if you've got x minus 3 all squared plus y plus 1 all squared equals 4. So I'll give you guys probably about 1 minute to have a go at this, and then we'll look at the answers together. Again, just as a side note, as you guys are doing this, if you are watching live, feel free to ask any questions, because I'll be sitting in the chat to answer your questions as well as we're going on. And feel free to pop your answers in the chat as well. So if you can find the domain and range, pop it in the chat as we're going on as well. So I'll give you guys maybe 20 more seconds just to have a go at this. Alrighty, so let's have a look at this question together. So again, finding domain and range is so much easier when you have a picture in front of you, because you'll actually be able to see, specifically with circles, they do end. There's really distinct points. So a bit of a tip there, your domain and your range for your circles is never going to be to infinity, because your circle is a defined little thing. So this is what we end up with as our circle. So we have center here at 3 minus 1. And we can see that because that's the opposites of our A and our B is 3 and minus 1. Then we've got 4 here. So that's r squared. So therefore r is equal to 2. So when you're drawing your circles, plot your center and then go 2 in each direction, and then just draw the curve around your circle. When you are drawing circles in your exams, your examiners are not looking for you to draw perfect circles. They acknowledge that it's hard to get the curve exactly right, but they want to see that you've got your center right. They want to see you've got these 4 distinct points, and then they just want to see sort of like a general, you've tried to draw a curve connecting them. They're not looking for exact, perfect circles. So we've got here 5 and -1, and +1 as our domain. So we can see that from our graph. Otherwise, what we can do is think if our center coordinate for x is 3, we just +2 and -2 on either side, which gives us the domain of x is between 5 and 1. And then we can see from the graph that our range is from 1 to -3. Otherwise, our y coordinate is -1, so we can just +2 and -2 to work out our range here as well. Okay, and then that's all you really have to do, or when you have to graph a circle. So in some cases, you're going to be given the equation of a circle with x squared plus y squared plus ax plus by plus c equals 0. And you're going to be asked to solve this. Sometimes if whoever's written your paper is nice, they'll tell you that you have to solve it by completing the square. Otherwise, they'll just give you that equation and you're sort of just expected to know that you need to complete the square. So the way that you're going to recognize this is because it'll be in your exam as x squared plus y squared. There may or may not be ax and by, but there will always definitely be x squared and y squared. And that's how you'll recognize that you've got the expanded version of the equation of a circle, and you're going to need to complete the square in order to find it. So that equation, when you've got x squared plus y squared plus ax plus by plus c, is essentially just the expanded version of the equation of a circle with a few of your factors missing, which is essentially what you're trying to create with completing the square. So by completing the square, you find the missing factors so that you can then find the whole equation of the circle. Now, completing the square is something that you do look at in year 10, which is why I don't have an example of it just yet. So what I'm going to get you guys to do is have a go completing the square for A and for B. I'll give you probably about a minute or so. See if you can remember it. If you don't, we're going to go through it together anyway. So see what you remember about completing the square, and then we'll go through the example together. Okay, so I'll give you about 10 more seconds maybe. Again, if you need more time, just pause the video so you guys can complete it. Or if you've had enough of waiting and you're not sure how to do it, you can skip ahead and look at the solutions. So when we are completing the square, what we do, we've got x squared minus 8x. We half this, we half our coefficient of x and square it, okay? So half of -8 is -4. -4 all squared is 16, okay? So we do the plus 16, then you've got y squared plus 10y. Half the coefficient of y equals 5, square that is 25. Now, what we've done on this side is we have moved our constant of 32 across, and then we've added the 25 and the 16 to this side as well, okay? Because essentially we can't just go adding like numbers into the equation. what we have to do is make it equal on both sides. So as long as we add 16 and 25 on both sides, our equation is still equal. So then we add the 25, we add the 16, and we end up with this equation here. Now, with the two examples that I've given you, I actually have given them to you in order. So I've got x squared minus 8x plus y squared plus 10y. Sometimes it'll come a bit muddled, so it might be like x squared plus 10y plus y squared minus 8x. First thing you want to do, arrange it so you've got your x's together, your y's together. Then half your coefficients and square them, making sure you add them to both sides. And then you'll get something looking like this. Now, from there, what you can do is go x minus 4. So in this case, x and whatever you halved. So the half of the minus 8 gives us minus 4, and we square that, okay? All in brackets. Same thing with the y's. You do your y plus whatever we halved, which was plus 5, all squared, and then that 9 comes from just doing that maths there. And then you can see here that you have the equation of a circle. So we can say our center is going to be at 4, -5, because we're just taking the opposites. And our radius is 3, because 9 is representative of r squared. So you get our radius of 3. Okay, so then looking at the second equation, if we had x squared minus 2x plus y squared plus 24y plus 120, again, recognizing that this has sort of been sorted out for you, all your x's are already together, the y's are already together. So what we want to do is we've got x squared minus 2x, half of 2x is minus 1 squared, we just plus 1 plus 1. Then same thing with the y's, we've got y squared plus 24y, half of 24 is 12, 12 all squared is 144, so we add the 144 to this side as well. From there, we can start creating our sets of brackets. So we open our first set of brackets with x, just our per numeral, whatever we halved, all squared, then y plus whatever we squared, which is 12, all squared, and then we do this math for 120, negative 120 plus 144 plus 1, we'll get 25. From there, we use our opposites to find the center of our circle. So here we're going to have a center of 1, -12, and our radius is going to be 5, because 25 represents r squared, so therefore our r is equal to 5. And that's pretty much all you need to know how to do with your circle. So then this is looking at semicircles. So the equation of a semicircle that's above the x-axis with center 0, 0 and radius r is going to be equal to y equals the square root of r squared minus x squared. So that will have domain negative r and r and range between r and 0. So that's when we have the center 0, 0 as well, so keep that in mind. And then when we have the equation of a semicircle that occurs below the x-axis, again with the center 0, 0 and the radius r, we're just going to put a negative in front of that square root sign, and that means it's going to be below the x-axis as well. So it's going to be the half of the circle that occurs below the x-axis, that's going to be concave up. So yeah, that's pretty much all we really need to know about semicircles for now. They're a little bit confusing when you start to move them around a little bit, so we won't go into that today, and I'll leave that for you guys to go into in class when you do functions. But just sort of knowing that in general this is what the equations of semicircles looks like is going to be enough for you guys for now.